So now let us move to the worksheet number 7 of Newton's laws of motion. So now let us move to the first question, children. A gun recoils after firing to conserve linear momentum. Conservation of momentum. Gun recoils. The bullet, whenever the bullet is fired, the bullet moves forward. As a result, the gun gives a backward jerk. Bullet is action part. Gun is the reaction part. So this is to conserve the linear momentum. Conservation of momentum. The momentum of the system is conserved always, never, only in absence of external force, or only when an external force acts. Only when in absence of external force. The law of conservation of momentum holds good when no external force is applied on the body. So hence, only in absence of external force, the linear momentum is conserved. That means momentum before collision is equals to momentum. Instead of saying collision, momentum before impact is equals to momentum after impact, according to the law of conservation of momentum in the absence of external force. So third option must be true. Let us look at the question number 3. So conservation of linear momentum is a direct consequence of which law, children? Newton's third law of motion. So from Newton's third law of motion, action-reaction pair, we can say that conservation of linear momentum holds good before impact and after impact. Action, reaction. Before impact, after impact. Momentum before impact is equals to momentum after effect. Before and after impact goes good with Newton's third law. Okay. Moving with the fourth question, a rocket moves according to the principle of conservation of momentum. That is Newton's third law of motion. So momentum, conservation of momentum based on Newton's third law of motion. Hence the correct option is option 3, that is Newton's third law of motion. So now let us move to the next question, children. Question number 5. When two bodies of masses m1 and m2 moving with velocities u1 and u2 in the same direction, collide with each other and velocities after collision, velocities becomes v1 and v2 after collision, again in the same direction. Then we know that according to the law of conservation of momentum, momentum before collision equals to momentum after collision. Momentum before collision must be equals to momentum after collision. Momentum before collision, first body, if you consider mass of the first body is m1, velocity of the first body is u1. Initially if it is doing, okay, first body, mass is m1, velocity is u1, and this collides with another body of mass m2, velocity u2. So after collision, masses though remain same, m1 and m2, its velocity changes. This velocity is v1 and this velocity is v2. But both are traveling in the same direction. This is u1 and u2. Okay. So before collision, what is the total momentum, children? m1 u1, and for this it is m2 u2. Must be equals to. After collision, mass is m1, velocity is v1, mass is m2, velocity is v2. So what is the, as they are moving in the same direction, so m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So the only correct option among them is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. That is fourth option is true. Let us move with the next question, that is question number 6. Here we go, children. Two bodies of masses m1, m2 moving with velocities u1 and u2 in the opposite direction. Earlier it was in the same direction, so I considered plus. Now they are moving in the opposite direction. So this body is m1 moving with velocity u1, another body m2 moving with velocity u2. After collision, m1 moves with together after collision in the same that together moving with common velocity, both moving with velocity of m1 is v, velocity is m2 is also v. Then the relation you're asked to find out. But how are they going? In the opposite direction. If one is moving in the forward direction, the other must be moving in the backward direction. Opposite direction. So now mass into velocity of the first body m1 u1, mass into velocity of the second body m2 u2, both in opposite direction. So minus positive direction, negative direction must be equals to mass into velocity of the first body m1v, mass into velocity of the second body same velocity v. So common velocity they are moving. First body also moving with velocity v, second body also moving with velocity v. So m1v plus m2v, or m1 u1 minus m2 u2, taking v as common, you are left with m1 plus m2. What you're asked to find out? The relation between these two. Is m1 u1 plus m2 u2 equals to this? No, because here it must be minus and here it must be plus. Wrong. Is it m1 u1 minus m2 u1? Not m2 u1, it must be m1 u1. This is also wrong. Yes, m1 u1 minus m2 u2 equals to m1 minus m2, not m1 minus m2. It must be plus. All the three statements are false. Let us also check with the fourth one. V must be equals to. Here let us try to find out the value of v. So keeping the v here, sending the other terms the other side, m1 u1 minus m2 u2 whole upon bringing this to the denominator m1 plus m2. So the velocity v is equals to m1 u1 minus m2 u2 upon m1 plus m2. Therefore, the correct option is option 4, that is v is equals to m1 u1 minus m2 u2 upon m1 plus m2. So this is the correct option. Okay, children? Well, moving to the next question, that is last one, seventh question. When a body collides with another body of same mass at rest, after collision, the first body comes to rest whereas the second body moves with the what velocity? Let us try to find out. So what is given, children? Body of mass m1, body collide with another body of same mass at rest. Another body m2, let us suppose that this is moving with velocity u. I'll take u1 as considered as u, and u2 is at rest condition. Body collide with another body of same mass, m1 equals to m2. m1 is taken as m, m2 is also taken as m. So let us recall this. When a body collide with another body of same mass, here mass same, at rest, second body is at rest. After collision, the first body comes to rest. After collision, the first body m1 whose mass was m, now final velocity v1 is equals to 0, whereas the second body moves with the second body whose mass is m. This velocity you are asked to find out. From the law of conservation of momentum, total momentum before collision must be equals to total momentum after collision. Momentum before collision, mass into velocity of the first body. Mass is m, velocity is u. So mu. Collision plus mass into velocity of the second body. So second body was initially at rest condition. Then mass is m, velocity is u, must be equals to final mass of the first body after collision m, velocity is 0. Mass of the second body m, velocity you have to find out. So simplifying this, mu plus m into 0 is 0 equals to this is 0 plus mass times of v2, or mu is equals to mv2. Simplifying this, m gets cancelled. Therefore, the velocity of the second body is found to be v2 is equals to, how much is that, children? The velocity of the second body is equals to the U, what is U? U is the velocity of the first body. So the second body after collision moves with the velocity of the first body. Velocity of the first body. Hence, option 2 must be true. The same concept, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. You have to understand the given question carefully and substitute accordingly to get the final answer. So this, when the first body comes to rest, second body moves with the velocity of the first body. Their velocities get interchanged because their masses are same. Okay. So with this we have completed with the worksheet number 7 of laws of motion. So children, always keep practicing, and until then, take care. Thank you, children.